Hi everybody, this is the start of chapter 6. Now you're probably wondering why we're going backwards in the book. There's a very good explanation for that. So chapter 10 has, I think, 7 sections to it, and we only covered the first 4. And then we tested. And now we're going backwards. We're going to do some factoring and some work with rational expressions that include factoring because we need that information in the back part of chapter 10. So most of you haven't encountered factoring or rational expression work, so we usually go backwards in the book and pick up chapters 6 and 7, and then we come back and finish 10. It's going to make things a lot smoother, a lot easier, and much more doable. Plus, for college algebra, we really need the factoring and the rational expression work, so that's got to be pretty solid. So we're going to take a look at, I think, how many sections do we have in chapter 6? We have 5 sections, and we're going to cover 4 different ways of factoring. And then in the last section, we're going to be solving using those methods. So let's first of all just talk about what factoring is. Okay? Hello. Come on, pen. Factoring. Most people hate factoring. It's one of the most used things in algebra, though. It's probably one of the most important concepts that we have. But let's just say that we had x squared plus 2. Okay, we've already seen this. We're going to, distribute. So we're going to multiply every term by 5, right? Well, factoring goes the other way. I'm going to be given this expression here, and I want to turn it into that expression over there. Or if we had a foiling problem, minus 1, okay, we've got our x squared, we've got our x, we've got our 2x, okay? So we have, I'm just going to do this really quickly here, x minus 2. Again, I'm going to be given this, and I want to get that. Okay, so it's just a backwards way of multiplying. It's just undoing the multiplication that you did, and that's called factoring. It's a lot harder to go from this to this than it is from that to that. So there's a lot more strategy, there's a lot more steps that we have to take, and but we'll get there, okay? So this first type that we're going to look at is called GCFs. What does that mean? That stands for greatest common factor. Greatest common factor. All right. So what do we do here? Okay, let's take a look at the one that we have up there. All right, so let's talk about what a factor is. All right, a factor is, let's just take an example of 10. What are the factors of 10? Well, I'm looking for the numbers that divide into 10 evenly. So, a 1 goes in there, a 2 goes in there, a 5 goes in there, and a 10 goes in there. So those are the factors of 10. Now, if I take another number, let's just say 4. Well, what are the factors of 4? Well, 1 goes in there, 2's go in there, and 4's go in there. Okay? So now, between these two numbers, a 10 and a 4, I'm looking for the biggest number that they both have in common. Well, that would be the 2. See how they both have a 2? So what I'm really looking for is the biggest number that would divide into each one of these evenly. That's what this is looking for. All right? So I ask myself, between these two numbers, between an 8 and a 40, what is the biggest number that divides into an 8 and a 40 at the same time? Well, I could list my factors like this if I wanted to. Or I can just look at it and say, well, I can see that it's an 8 because 8 is divided by 8 and 40 is divided by 8. Okay, so that's what we're going to be doing, is we're going to be pulling the GCF out. All right, I'm going to go back up to this one. You see how this is my GCF between my 5 and my 10? It's my GCF over here. Now I'm going to look at my variables. Now my variables are much easier. I'm always going to pick the lowest powered variable. Between the two I have a 1 and a 2, so I'm going to pick 1. Okay? So numbers are much harder to find the greatest common factor. Variables between like bases, you just pick the lowest power. Okay? Now to find out what's left, basically what I'm going to do is I'm going to divide each term by 8x. So I can do this and simplify each one of these and put it in here. So 8 divided by 8 is 1, so the 8's are gone. And x squared divided by x is x, so that's all that's left there. I'm going to match my sign, and I'm going to do it again. 48 divided by 8 is 5, and x divided by x is gone. So this is my answer. Now, in order to determine whether or not I've done it right, I would want to remultiply. 8x times x is 8x squared, and 8x times 5 is a positive 40x. See, I get back what I started with up here. So every time that you factor, you have to remultiply to check them. Okay? So this is one type of factoring problem that has a common factor within it. Each one of these terms has something in common, and they have an 8x in common. Let's try another one. All right, so we have 35y cubed minus 5y squared. Okay, take a look at the numbers. 35 and 5. What's the biggest number that divides into each one of those evenly? 5. Now look at your bases on your variables. We've got y terms. The lowest power is a 2, so that's what I'm going to take out. Now I'm going to divide each one of these by 5y squared. (35 divided by 5 gives me 7. Y cubed divided by y squared gives me y. I match my sign. 5 divided by 5 is 1. Y squared divided by y squared is 1. Remultiplying, I get 35y cubed minus 5y squared. That's what I started with. Excellent job. I'm not going to put those in there. Too much work. And I know that they're right, so because I'm remultiplying. Okay, 48x to the 6th y minus 6x5y squared. All right, so again, we're going to start with the numbers. We're going to see what divides into a 48 and a 6 at the same time, the biggest number, and that's a 6. And I've purposely chosen some pretty easy numbers for you. 6 goes into 6, 6 goes into 48, 8 times. Now I'm going to look at my bases. I've got x's and I've got y's. So my lowest power on my x's is a 5, and my lowest power on my y's is a 1. So I'm going to divide through by my GCF, both terms. Okay, 48 divided by 6 gives me 8. X to the 6th divided by x to the 5th gives me x. And y1 divided by y1 is 1. Match my sign. 6 divided by 6 is 1. x5 divided by x5 is 1. And y squared divided by y to the 1 is y. Done. Okay? I don't know how many of these I'm going to do. Probably not. Oh, these are a little different. What is the greatest common factor? And then you probably have to factor it after that. These are just factoring. So here they're asking you for the greatest common factor. So that's just asking you for this piece of it. And then to factor. So some of these, and 3 terms, same thing. right? Well, let's do a 3-termed one. We haven't done one of those yet. But we're doing exactly the same thing. Okay. Between the 3 numbers, I need a number that goes into a 20, a 12, and a 4 all at the same time. Well, that's a 4. 4 goes into 4, 4 goes into 12, and 4 goes into 20. Then I'm going to take my lowest powered x, which is 1. I'm going to divide each term by 4x. (20 divided by 4 gives 5. X cubed divided by x to the 1 gives me x squared. Negative 12 divided by 4 gives me a negative 3. X squared divided by x is x. Positive 4x divided by 4 is 1, and x divided by x is 1. So make sure that you put that in there. A lot of people go, oh, well, this is gone, but it's not. It's really a 1, because if I would remultiply, I wouldn't get that last term back, so it's very important to have that. Okay, so here we would say the greatest common factor is 4x. Let's just do one of these, right? And then the factored form is this piece of it down in here. So let's not be lazy, Simone. 5x, since I started it, minus 3x plus, that's not a plus, 1. Okay, 5x squared, yep, that's right. Okay, good. Okay. Same thing here. Nothing's new. Same thing here, nothing's new. I'm just going to go through these and see if there's anything. Okay, these are different. All right, so here we have two terms. Here's my first term, and here's my second term. They just look different, right? Just because inside the parentheses I've got some stuff going on, but I'm still looking to see what do these two things have in common? Well, they have the x plus 2 in common, don't they? So that's your GCF. We're doing the exact same thing. So I'm going to divide through by x plus 2. Divide through by x plus 2. Nothing's changed, it's just looking a little different. X times x plus 2 divided by x plus 2 gives me x. And minus 5 times x plus 2 divided by x plus 2 gives me minus 5. Done. See how that works? We're getting ready to start grouping here. Okay, so this still has a GCF. Let's try this one. So here we have 6x cubed, x minus 2. There's one term, minus 3x, x minus 2. There's another term. So again, I'm going to look to see what they have in common. Well, they got a lot in common, and this one's going to be a multiple stepped one. But I'm going to first of all look to see that they have the x minus 2 in common. That's the most obvious thing that I see there. So if I would divide through by x minus 2 and divide through by x minus 2, then this is gone, and all that's left there is the 6x cubed. And these are gone, and all that's left is this minus 3x. Now normally I would, I would go, oh, okay, I'm done. I did my one thing and I'm finished. And so far we haven't had to look any further. But what you need to do is when you recreate some new pieces here, you have to look to see if there's anything that you can do further with those pieces. Now this one, there's nothing that the x and the 2 have in common, but here, this is not factored fully. These have a 3x in common. So this is not completely factored. I have to keep going with it. So I'm going to go off to the side here and do this piece of it. Okay, between a 6 and a 3, they have a 3 in common. And between an x cubed and an x to the first, they have an x in common. I'm going to divide through by 3x and divide through by 3x. 6 divided by 3 gives 2. X cubed divided by x is x squared. Minus 3 divided by 3 gives a minus 1. And the x's are canceling. Okay? So this is the factored form of this. Now I'm going to look to see at this point, I've recreated this now, but there's nothing in common with that one, so now I'm done. So I'm going to have my 3x, my 2x squared minus 1, and then don't forget about that piece, x minus 2. Doesn't matter on the order. You could put these all in different orders and it has no effect on it whatsoever. Even these up here. You could do x minus 5 times x plus 2. Because this is all multiplication, 3 times 2 is 2 times 3, so it doesn't matter on the order. Okay? All right, so what that was doing was that was getting us ready for grouping. Now, factor by grouping is a method that we're going to use in our later in our trinomials. So we have to learn how to do this. So factor by grouping is always a 4-termed polynomial. Now look at this polynomial. Tell me what they have in common. Between a 1, a 2, a 9, and an 18, what number divides into all of those evenly? Well, it's just a 1. That doesn't ever do us any good. And between an x cubed, an x squared, an x, and no x, what's the lowest powered? No x. So there's nothing that they have in common. So you would almost think that there's nothing that we can do. But we have a grouping technique that we can use. So what we're going to do is we're going to group the first 2 terms together, and we're going to group the last 2 terms together. And we're going to look at them individually. So I'm going to ask you, just between just these 2 terms, do these 2 things have anything in common? Well, between the 1, I'll just put that there, the 1 and the 2, there's no number that they have in common, but they do have an x squared in common. So I'm going to pull that out as a GCF just between these 2 terms, divide through, okay, x cubed divided by x squared is x. And then here I have x squared divided by x squared. Those are gone, but I have the plus 2 left over. So at this point, since this is multiple steps, I'm going to just quickly redistribute. There's my x cubed. There's my 2x squared. I'm always going backwards to see if I have what I originally had. Now I'm going to do the same thing on these 2. Okay, I'm going to look to see what they have in common. Well, between a 9 and an 18, they have a 9 in common. So I'm going to say it's a positive 9 in common. Okay, between the x and the no x, I can't take an x out. The lowest powered is 0 x's. So I'm going to divide through by 9. Divide through by 9. 9 divided by 9 is x, right? Well, no, 9 divided by 9 is 1, and so there's the x left over. And 18 divided by 9 is 2. Now, do you see this turned into the problem that looks like that? It's very similar to that. So we're taking this 4-termed and we're trying to get it into this 2-termed polynomial. Okay, so that's our goal. Now I look to see between these 2 terms, what do they have in common? Well, they have the x plus 2 in common. So I'm going to divide through by x plus 2. Divide through by x plus 2. Okay, and we'll see what's left. We have the x squared plus a 9. Now I always have to look to see if I can do anything further with what I've created here. There's nothing in common with these, so this is finished. I don't have anything in common between these 2, and I don't have anything in common between those 2, so then I'm done. Okay, that's called grouping. Should we try another one? Yes, please, let's do another one. I'll answer for you. These lectures in chapter 6 won't be too long. Maybe one of them will be. But these won't be real bad, and I haven't put a whole lot of homework in these. Okay, so again, we're going to group and group. The front two, the back two. Between a 6 and a 9. Now, we haven't done this yet. What's the biggest number that goes into a 6 and a 9 at the same time? Well, it's not 6, because 6 doesn't go into 9, but it's 3. Okay? And between an x squared and an x cubed and an x squared, we're going to choose the x squared. So I am going to divide through by my GCF, both terms, and I will see what's left. 6 divided by 3 is 2. X cubed divided by x squared is x. Negative 9 divided by 3 is a negative 3. And x squareds are gone. Now I'm going to go over to these two terms and do it again. Between an 8 and a 12, what do I have in common? Well, a 4 goes both into those. A positive 4. That's the biggest thing that divides into both of those evenly. There is no x term here, so I can't take any x's out. So I'm just going to divide through by 4, divide through by 4, see what's left. 8 divided by 4 is 2. I've got this x left over. Negative 12 divided by 4 is negative 3. Now do you see how these are always matching, these back pieces? They have to match in order for this grouping system to work. Okay, if these don't match, then I'm stuck again. All right, so in order for this stuff to be factored, you have to create these back binomials to be identical. So now each one of those has a 2x minus 3 in common, right? So I'm going to divide through by 2x minus 3, divide through by 2x minus 3. These are gone, so all that's left here is a 3x squared. These are gone, so all that's left is a positive 4. And I analyze again. There's nothing in common between these two terms, and there's nothing in common between these two terms. So I'm finished. Now, how do we check to see if that's correct? Well, let's FOIL it. All right, let's just see. Let's redistribute. There I have my 6x cubed. There I have an 8x. Here I have a minus 9x squared, and here I have a negative 12. That's exactly what I started with in a different order, but who cares, right? I've got the 8x first and then a negative 9x squared. As long as all the signs are the same, it doesn't matter on the order. So I do have what I started out with. Okay, so if I break it apart like this, it's exactly the same as that. And again, oh, this one's different. Gotta do this one. I was wondering if there's one like this in there. Probably doesn't look any different to you guys. Looks different to me. Okay, front two, back two. Oh, we're getting some bigger numbers now, aren't we? Between a 16 and a 28, what is common? The biggest number that's in common between a 16 and a 28 would probably be a 4. 4 goes into 16 and 4 goes into 28. I don't know that if anything else goes in there that's bigger. So we'll take out a 4. Now between an r cubed and an r squared, we'll take out the square. We're going to divide through, come on, I'm pressing that stupid button on this stylus pen again. We'll see what's left. 16 divided by 4 is 4. R cubed divided by r squared is r. 28 divided by 4 is 7. And the r squareds are canceling. Okay? Now here we have two negative numbers. And remember I said these back, here, let me go up here. These back pieces right here need to match. Okay? So if I would take out a positive 7, the back pieces aren't going to match. So I have to take out a negative 7. Because there's a negative, they're both negative. So I'm going to take out the negative 7 and I'm going to force these back pieces to match. So what I'm doing is I'm looking at a 28 and a 49, and the biggest number that goes into both of those evenly is a 7. But I'm going to pull out the -7. So I'm going to divide through by negative and negative. See how the -28 and the -7 makes a +4? See, this is a +4 over here. If this was a +7, I would get a -4 over here, and then they wouldn't match. Okay? So there's my 4. I've got the R still. -49 divided by -7 is a +7. So these have to be the same. So therefore, I've got to pull that negative out here. Okay, now these two terms have the 4r plus 7 in common. Right? So now I'm going to divide through by 4r plus 7 both sides. Here, 4r plus 7. So these are canceling, so all that's left is the 4r squared. And these are canceling, so we've got the -7. And again, nothing in common. So if I was to remultiply, I would get back this. Okay? Same thing. Nothing new there. I think I'll leave you alone. And same thing. So that's it. See, these are going to be short. This is only like under a half-an-hour video here, so that's kind of nice. So we have two types of factoring in here. We've got the GCFs and we've got the factor by grouping. Now we're going to be moving into some trinomial work. I've got two different types. 6.2 is one type, 6.3 is another type. And then we're going to move into the difference of squares in 6.4. Then we'll start using all this knowledge in the rest of 6 and 7. Okay? So get some practice in, and I will see you for the next section. Take care.